Good morning, everyone. Welcome. We're very excited to have you all here for another Tech Talk with the goal of, creating learning experiences throughout the year and hearing from our various Harvard colleagues from around the university on things that we're working on. So very happy here to have Davika Jain, who works for the Faculty of Arts and Sciences as a data science project manager. And she's going to be talking to us today about some geospatial data work that her and her team have been doing. So without further ado, Davika, take it away.
Thank you, Deirdre. Hello, everyone. Good morning. Can everyone see my screen and my slides?
Yes.
And I'm audible, right? Uh, well, my name is Devika Jain, and I am project manager for geospatial data science and big data here at Center for Geographical Analysis. And we are part of IQSS and FAS. And today I will be talking about my work, our project, which we recently completed on building a robust infrastructure for spatial data science and big data across the university. And thank you first for the HUIT team for giving me this opportunity to present my work to our colleagues. Before I go into my slide and describe what we have done and why we have done, I would like to give a little bit overview on how this project started and how we started thinking about this kind of infrastructure. So a few years back, there was a change in the type of projects which we were seeing coming to us. That was mainly because of the change in the geospatial data itself. So the geospatial data was growing due to increased sensors, the increased quality of sensors, and the geospatial data was growing vastly. So we were not no more dealing with thousands of points, but we were dealing with billions and millions of points. And that's when the researcher were coming to us with great ideas, with complex problems which need to be solved using this big geospatial data. That's when we started thinking about how do we enable this kind of projects, how do we enable research using geospatial big data, and we realized that we need a whole infrastructure to support this kind of work across the university. And that's how the idea of this infrastructure to enable researchers to do this kind of spatial data work came in. And when we started thinking about it, we were just thinking about what this infrastructure could look like. What do you mean when you say geospatial infrastructure for big data? And we realized that there's no single answer. There's no one product, one solution, which you can provide to people and say, hey, this is the all tool which will solve all your spatial data problems, especially big data and data science issues and GeoAI now. Uh, so we thought about that we need a suite of products, and we need a toolkit which would enable researchers. And for us, these toolkits consisted of cutting edge geospatial software installed on our high performance computing, installed on our cloud infrastructure. It also consisted of custom based solutions designed for specific big data use cases. It consists of uh, integrated data sets, because you can have the software but you also need the data to support to work in those software. So it consists of data sets which we have developed. More importantly, it consists of interdisciplinary collaboration within our team and our researchers and our IT team to build this infrastructure. And lastly, we also thought that it is very important to enable our users to educate our community on how to use this big data and data science tools. To do this, we started looking for resources which are available to us to enable this kind of work. And we focused mainly on our in-house resources due to the cost savings. And the two resources which we have widely used in this work are our FAS Research Computing, the high performance computing cluster provided to us, and the New England Research Cloud, which provided us the cloud computing resources. So, as I said, that we realized that there was a need of different specialized solutions, specialized infrastructure to support this kind of work, mainly because we were seeing that the big data, the geospatial big data comes with certain challenges, and it also comes with opportunities. And to make use of those opportunities, we need to first tackle the challenges. So what we were seeing that what were the main challenges in this data sets were the three V's: the volume, the velocity, and the veracity of this data set. It was coming in large volume, it was coming at a high speed, many times it was coming real time, and it was diverse. It was integrated sources. It was not coming from one source, it was coming from different sources, different images all together in one. So we had to deal with the three ways here. Then the analysis and visualization of this data is not straightforward. It is a complex issue because we have to look into the coding requirements. We have to look into how we optimize the visualization for this big data and how we do the resource management of this data set. Then again, we also wanted to focus a lot on the efficiency and scalability of these systems, because how do we get them deployed on our cloud system? How do we optimize our algorithms for cost time balancing in the end is the key here. How do we minimize the processing, the visualization, the analysis time of these data set to achieve the minimum cost saving for our researchers? And with these things in mind, we started thinking of approaches which we will take to enable this. And these are some of the approaches which we initially thought of. And these build the foundation of our work, and then we build on these further to enable the research. So firstly, we thought that this kind of work which was coming to us, or these kind of projects, one of the thing which was common in most of these projects was that they were the traditional geospatial systems or methods of solving problems were limited in their approach to solve these kind of problems. So we started thinking of how we can move our processes from desktop to cloud to enable this kind of data set and this volume of data set. Then again, we also not only moving the processes was important, but also moving the data along with the processes. Because if your data is local and your systems are on cloud, then the input output time is so high that you lose the benefit of moving your processes on the cloud. So at the same time, we started thinking of how we move our data in proximity to the tools which we are designing on the high performance computing clusters. So moving the processes, moving the data was one of the key steps which we took in this project. Then, as you all know, and as you all might be using right now, GPUs are our big thing right now with all AI coming in. So is with geospatial AI, that using GPU based solutions or designing GPU based solutions for our community to use was another key approach that we took in the process. Then scaling our applications, because at our center we deal with different projects which are coming from different units of the university, and every project has a different requirement. It has different set of resources and funding available to it, so we have to customize a solution according to match the researcher's need. And one of the key things in doing that was auto scaling our applications. So if your project does not need 100 GPUs, then you don't have to use them. You can scale down and you can scale up. So auto scaling was one of the key things which we kept in mind when designing our approach. Then another last but very important one was containerization of the applications using Docker, because many researchers who come to us, they are not very skilled in deploying the geospatial applications. So we wanted to take that load off from the user on our plate so that we can handle the installation of these geospatial tools, or we can make them Dockerized, or we can make our solution Dockerized so the researcher can focus on the research question and we can deal with the black box of handling the geospatial installations and processes at the end. And I will show you examples of how we have applied these approaches in the different solutions that I will present going from here. So as I described, that we use two foundational computing environment for our work. It is also because the kind of projects which we deal at CGA, they are basically can be divided into two big groups. One kind is short-term projects where people come to us with some kind of research they want to do in short term, or just do the analysis, get the results. So they need on-demand resources. And for on-demand resources and short-term projects which need computing resources only for a short bit of time to do those calculations, FAS research computing was a very good fit for us. So we enabled our processes on FAS research computing to support our short-term projects. Then there are projects across the university which have more long-term computing needs, and they need dedicated cloud infrastructure to host their work. And for that, those kind of projects which have these kind of long-term needs and they need dedicated resources, New England Research Cloud was our to-go solution. So all our infrastructure is designed with a combination of both NERC and FASRC in mind. So as I said, what we have developed is not one solution or one product. It is a suite of product. It consists of system deployment, what systems are deployed and available to the community to use on these cluster and cloud resources, what custom-based solutions we have built, and what are the integrated data products we have built. And I will go through each of them in detail so that you can know what is available to you as a resource now.
And we
So
actually did have a question that came into the chat on how are you managing Docker security issues? Are you porting to Singularity?
yeah, that's a great question. Yes, we are porting to Singularity. Probably I'll get. Can I get to all these questions in the end? These are great questions. I'll first finish the presentation because many of the questions which will come might be answered in my slides going forward, and
Okay, sounds good.
I will describe some of that. So we did system deployment, and when we were doing this system deployment, we thought of cutting edge GIS software, which are handling GeoAI, which are handling geospatial data science and big data, and we deployed them on both our cloud and cluster computers. And we did that using Docker and in FastRC, it was done in Singularity to deal with the security issues. The four softwares which are now available to the community for use are ArcGIS Enterprise. This is S3's solution to handle their big data and data science. So it is a very good tool to use if you are into using S3. And now you can launch this on New England Research Cloud. We have the machine image saved with us. So you can take our machine image and you can use that to launch ArcGIS Enterprise, which makes the installation really easier for everyone. And to work with ArcGIS Enterprise, we have also acquired Global Street Map Premium license. So around the globe, you will have this data set to work with network routing or other kind of problems which you are looking for S3 data. Again, we have two spatial databases installed. The first database is PostGIS, which is a very commonly used open source software. It's a CPU-based spatial database. So if you are looking for spatial databases for your project, then this could be your to-go place, because now you can launch PostGIS on FASRC using the VDI launch. So with VDI, all you have to do is to like you launch Jupyter Notebook on FastRC. Similarly, you can mention your RAM, how many CPUs you need, and just with one click launch, you can get PostGIS running, because we take care of the installation at the back end with the Singularity containers. So if you are looking to scale up your PostGIS application, or you are looking for scaling databases, then PostGIS on FastRC would be a good choice for you to look into. Then moving from CPU database, we also have GPU databases. Working with our collaborators at Heavy AI, they provide GPU-based spatial databases. So if you have large amount of data that needs visualization, that needs GPU power, then Heavy AI could be a good tool for you to look into. And you can launch Heavy on FASRC using the VDI. And similarly, you can also launch it using our Docker container on NERC. Then again, we have NIME, which is an end-to-end data science tool for building workflows. If you are looking into building workflows, particularly spatial workflows, then NIME could be a good tool for you to look into. And our team is working to enable and develop a lot of spatial extensions on NIME. So NIME now comes with a lot of spatial extensions which are developed by our team, which you can use to make the spatial workflows in NIME. And again, we now have a remote desktop-based NIME on FastRC, and also a Docker-based launch on NERC. Now, I described a little bit about the software which is available for the community to use on both the cloud and cluster computing environment. Now, I would like to talk a little bit about how we have used these different software to build customized solution. So there are a lot of projects which have been supported by this infrastructure already. However, I will only cover those which are very generalized and common problems in spatial science so that others can also make use of it. And one of the first system which we designed is called raster information extraction system. And this is one very common uh, project or one very common use case which we were seeing in big data, that people were coming to us with big, huge raster data sets, whether it's climate data, it's nightlife data, nightlight data, or NVDI. And they wanted to process these rasters or to get information from these rasters at a very granular level, at address level. So this involved a lot of analysis, spatial intersection that is very cost consuming and resource consuming. So this for this particular project, it is a use case from Harvard Medical School, and the researchers there were trying to extract climate information for 7 climate variables across the United States on 800-meter raster, that is a fine resolution raster, to work with for 43 years of data. So in total, they wanted to extract information from around 100,000 rasters, and that was about 10 terabyte of database to process in raster. And they wanted to they wanted to analyze the climate variables at address level. So for every patient point, you analyze all the 7 climate variables. So this resulted in the end in 163 million calculations at address level. It's a very fine-grained spatial analysis. But for this, we used our Docker-based Postgres running on New England Research Cloud, which helped us to do this analysis in just 2 days for these many calculations. And if you do this using other tools like Python or R, this analysis itself could take you from weeks to months. And this has been done by our by researchers, and they have realized that how time consuming and resource consuming this process can be, and the data updates on a daily basis. So by the time you finish your analysis, the data has already updated by a month or so. So timely analysis is very important in these kind of data sets. So this solution is now helping researchers, is transforming the way raster data set is being processed, and the speed and cost in which this can be processed. So you can easily see that we took about 2 hours to load this and about 2 days to calculate this uh, solution. So if you are into big raster data processing, you are looking for solutions to process big raster data, then please look into this tool. It is an open source software available on GitHub. So you can pull our software and you can customize it to read your raster, or we can help you to customize the solution to your raster. But this is definitely something you would like to look into if you are into raster processing. Then another very important or very common use case which we get is from people calculating shortest travel time, and particularly from our colleagues at medical school and School of Public Health. They do a lot of health accessibility analysis, and for that it is very important that we have efficient methods to calculate the shortest travel time between the patient and the hospitals. So till you are working with thousands of points, it's easy. There are a lot of solutions out there you can use. However, when you cross a certain number of points, when your data is big data, then there's a lot of cost which comes with these commercial solutions, because they are only free up to a certain point. And if you have more ODs than needed, the origin and destination points are huge, they are in millions and billions, then the cost is too high to calculate using any available method or software, commercial ones. So that time we started thinking of how we can handle the shortest travel time problem on big data, and how to provide our colleagues with a solution which does not cost them thousands of dollars to just calculate this shortest travel time. And that is when we developed this open source solution. It is based on OpenStreetMap data, which is free, and it's based on an algorithm called open source routing machine. It's again OpenStreetMap solution, and this allows you to upload unlimited number of origin and destinations globally to calculate the shortest travel time. And it is quite accurate, and the results are very similar to what you will get in Google. And it is quite time efficient because of the cloud infrastructure we have used, and because of Docker and other optimization that have been done. And this can allow you to calculate up to 20,000 ODs per minute. So it's a fast and efficient solution. And if you are looking into shortest travel time calculation, please do reach out to us to learn more about this solution, as well as other solutions we have designed for this particular problem. Then another interesting case was which is also very common in spatial analysis, is routing or optimal route or network analysis. And for this was a use case from our colleagues at Harvard Kennedy School. So they were looking into a pipeline project, that which is an optimal route to lay the pipelines across United States for their work. And for this, it's a very fine resolution raster. They were using 200 meters, about 20 gigs of data that needs to be processed to find these eight optimal paths across the United States. So again, it's a lot of raster processing which was involved in this on big data. And for this, we have used ArcGIS Enterprise, because ArcGIS Enterprise has a lot of routing tools inbuilt which can be used. With ArcGIS Enterprise on cloud, we were able to scale the application to handle this fine resolution raster to do this optimal path calculation across the United States. If you are looking for this kind of work which needs optimal path calculation, then ArcGIS Enterprise or NERC could be a good tool for you to use. Then I talked a lot about analysis, whether it's shortest travel time, whether it's optimal path calculation. Now I would like to move a little bit into the visualization, because the analysis of big data is complex in spatial, but the visualization is even more complex, because you need to keep it real time. And ultimately, when people come to us, they want a good looking visualization, want a good looking map out of this big data. So when we were thinking about how we enable visualization on these kind of data sets, one of the thing which we used heavily is GPUs and GPU databases. One of them is called Heavy, which is a company which we work with to provide this kind of visualization. And this particular project is our collaboration with National Geographic. So Paul Salopek is a journalist, and he is walking across the globe. And as he is walking, he is sending us his GPS points to map. And these GPS points not only have the latitude, longitude, they have a lot of other information: elevation, which country he is in, what is the population, so on. So till now, we have about 2 million points with 14 variables. So this started with a paper map, but now we have changed it. We are working on changing these kind of maps and projects into interactive interfaces, which people can use to query this data in real time on space, time, and keyword. And I will show you a short demo on how this thing is, what we are building. So if you see here, you see this is the route of Paul's walk across the globe. And it also shows this tool allows you to do the statistics. So a lot of data science can already be done. What is the records by country? What is the elevation at different points? What is the distribution of land cover to where Paul is going around? However, the cool part about it is it does allow you to add filters. It allows you, like for example, I'd say it, find me all points in Paul's walk which are in India. So you can say country India, and then enter the name, and it will show you the points in India. Maybe I'll show that end part again. So this is the kind of tool sets which we are trying to build. Let me show you. Where's my Then this was the user interface, no code user interface, where the user does not need to code anything. They can do the spatial data science very easily by using this kind of interface, which allows you to filter on space, time, and keyword. But right now, since everything is about Gen AI, LLMs, so we also started looking into how we can enable our community to use LLMs and Gen AI to answer questions and get answers in natural language on spatial data sets. And this is one of the tools we have been working to produce this kind of capability. And uh, I have a short demo of one of our data sets and how this capability works on that data sets. So this data set is actually a collection of geo tweets, every tweet which has lat long. We have collected these tweets from 2010 until 2023, and now we have about 10 billion tweets in the data sets. And I will talk more about the data sets later in the presentation, but one of the key things, one of the key questions which we get on this data set, and this data set is widely used across the university. Many researchers who are working with social media, who are working with the spatial data set, they use this data set for different use cases. The interdisciplinary research on this data set is huge. So many people, they come to us and say they don't have the required coding information or coding knowledge needed to work with a 10 billion spatial data set. So one of the questions we normally get is, hey, can you just filter it on space, time, and keyword I am providing, or get me all tweets in United States talking about COVID? So this is the kind of question which we want to make our community self-reliant to answer. So one of the ways to do that was use Gen AI and LLM. So without any kind of geospatial knowledge or coding skills, you can go and ask these questions and get answers. And let me show you a little bit of teaser of what we are building. It's still a work in process, but what we have built so far. We can ask simple queries about the statistics of the database, like find the number and time period of geotweets. So it uses our initial prompt, changes it to SQL, and then there is the answer in easy to understand natural language. There are 400 million geotweets, with the first on January 1, 2023, and the last on July 12, 2023. Similarly, we can do simple spatial analysis like the spatial variation of tweets by asking questions like show the location of tweets mentioning the word earthquake. Here we see the SQL generated and the resulting visualization of the tweet distribution. This leverages the power of GPU rendering to plot large geospatial test results. And we also see a large concentration around Turkey Syria region where the earthquake took place in February 2023. Getting to slightly more complex query, we can do spatial temporal queries such as asking the percentage of tweets by day of week and hour of day mentioning the word mimosa in United States. Here you see the complex query that is generated with the spatial temporal joins, and also the visualization which shows that the word mimosa lights up on Twitter around Sunday afternoon time. So this is the kind of capability that we are working on to see where is yeah, this is the kind of capability that we are working on to enable more and more people start using big geospatial data set using Gen AI. We can ask simple queries about moving from our systems from analysis and visualization. We did also develop all these systems need to work with data. So we also developed some spatial enriched data products which could be used for different research use cases. And one of the data products which we developed is called GeoTweet Census Archive. So as I described that we have this collection of 10 billion geotweets from 2010 to 2023, covering the whole globe, multilingual data set. It's like a gold mine of social media data. So if you are doing research on social media data set, this could be a good one for you to look into. So what we did is that to enable researchers do very granular analysis of this data set, we went and we enriched this data set for United States. We enriched it for uh, census block IDs. So this was actually for a project from our colleagues at Department of Gov. They wanted to analyze the voting behavior using using the GeoTweets. So they wanted to link it with the voter file, and to link it with the voter file, we need to enrich it with census blocks so that we know which is coming from where. And also it helps you to bring the social economic variables and combine them and integrate them with social media to see the interaction between the what people are saying online versus what is actually the situation on ground. So it helps you to bring a lot of CDC and other social economic variables and health variables into a picture with spatial data. So that was one of our key motivation to go and enrich this. And this enrichment was very intense because we were enriching about 2 billion tweets with 8 million, around 8 million census blocks. So it's a lot of spatial interaction, special processing that is happening in this interaction, in this enrichment. And we did multiprocessing, we developed a multiprocessing solution on GPUs and CPUs on high performance computing. And this data set is available to all researchers. This enriched data set is also available to all Harvard researchers. And uh, we this will allow you to do real-time analysis at census block level on over a decade of data. And the novelty of this data set is the temporal and the geographical granularity that this data set is providing. Similarly, this is a very interesting data set that we have developed uh, out of this work, and it's actually we went in and sentiment stamped. So we did two kind of enrichment on our tweet data. One, we did geography enrichment. For United States, we enriched it on census block level, and for the word, we enriched it on admin 2 level. So every tweet notes the admin boundary from which it is coming from globally, and it notes the census block from where it is coming from in United States. We also did a sentiment stamping, and with that sentiment, we came up with a proxy for subjective well being. How your online behavior, what your online behavior or your online tweets tell about your subjective well being in general. So, this data set is again, this is open source, publicly available data set, which you can, it's about 8 billion tweets enriched with sentiment and geography. And uh, this is again global coverage for 10 years, and this data set was actually picked up by United Nations SDG group as part of the SDG Today data set. So it is now hosted on SDG Today, and you can also refer our Nature paper to read more about this data set and how you can access it. Then, as I described, that one of our key, after we built all these things, one of our key objective was to enable our community to start using these tools and data sets, because if nobody is using it, it doesn't make any difference to how spatial processes are being handled. So for this, to enable our user and our community, we have designed, and we are actually still working on this part of the project where we are working on user training and enablement. And we have designed workshops on how to use Python for geospatial big data science, how to use ArcGIS Enterprise for geospatial data and data science. So all these workshops are recorded, and they are now available open access on YouTube. So if you go on YouTube, you play the workshop, you will see that it's a chapter wise workshop where you can go and actually do a hand on exercise and see how do you use Jupyter Notebook to run spatial processes on FastRC. And also there are a lot of self-led tutorials which we have developed, which will help you. How do you launch PostGIS on FastRC? How do you launch ArcGIS Enterprise? So these are self-led tutorials available on our website, and I will show you where to reach to these resources later in the presentation. And we have an upcoming workshop this Friday on May 16th on using web AI for geospatial analysis. So if you are interested in using web data, web data particularly for spatial analysis, then this workshop could be a good one. It's a full day in-person workshop at CGA. And also next week is our annual conference, and it's a very interesting theme for this week. It's the geography of digital twins. So if you are looking into digital twins and what it means for spatial, then it could be a good one to come and hear to from the leaders, top leaders in digital twin for spatial. As I said, we talked a lot about what we built. I want to talk a little bit about the results of the project and the impact that this project has created so far. So we have a lot of publications which are already in reputed journal, or which are in work in progress, and ranging from Nature to other reputed journals. And not only these are not only our publications, but publications from our colleague across Harvard whose research has been enabled by this infrastructure. And we also have this GitHub repository, which I described, where you can find, for every project, you can find the open source code, which is freely available for you to fork and start using and change it in a way you want. But all codes are on our GitHub repository. Then this project is got a lot of media coverage and news articles are there, particularly from Mock Alliance covered it to show how you can use Spatial for New England Research Cloud. So all these resources are available on our website for you to look into to understand more. Then, as I said, most important is the feedback from our community, from our users who are using or will be using these products. And as you can see, the researchers have given us, provided us their feedback to show how they have used the data and how infrastructure and how it has enabled something which was not possible earlier. So if you have time, do look into these testimonial, not only to show how good the infrastructure, but also to see how people are using the different products in different research use cases, which is very interesting. And also feedback from our colleagues who attended the workshop and who think that how the workshop is enabling people to, particularly students, not only to use these tools, but also to prepare them for the geospatial job market, because these are the cutting edge tools which are being currently used in the spatial industry, and they are widely in demand when person goes out to look for jobs. So now moving from the technical part, a lot of learning from this project, a lot of strategies and best practices, but I would like to share the key ones which we used, which helped us a lot in designing an efficient infrastructure. And one of them was, again, migration to cheaper resources. If it is an on-demand work, we use our free FASRC cluster. If not, then we use NARC. But it's not one solution for all. It is a case-by-case basis that we decided then what computing environment we have to use, what software we have to use, and what tool we have to use. Auto scaling of applications helped us a lot because every project had different needs. So we didn't want a solution which a person cannot scale up and down. So all these solutions can be scaled up and down. We did keep our applications power off when we were not using it. It saved us a lot of cost on the cloud computing particularly. And multiple projects were run on the same resources. Like if we run a Postgres instance, we were running 2 to 3 projects on that Postgres at the same time. So while the infrastructure cost remained the same, we were able to complete 2 to 3 projects and thus under that same Postgres instance. Then on-demand applications, again, for FastRC, a lot of cost saving. We focused a lot on optimization, our computations, like how do we optimize our databases, how do we do the spatial indexing, what are the database optimization capabilities which we use when we design our solutions, because one is resource optimization, which you do on the computing environment itself, and the other was actually how well your code is written, because if the code is not well written, then the resource requirement increases infinitely on its own. So we focused a lot on our computing requirement. Then again, using OpenShift containers, using Dockers helped us a lot to launch the processes as and when needed. It also helped our users to not worry about the backend of these installing these geospatial systems, and they can focus, and the system is ready for them to use to focus on their research use cases. Now, infrastructure projects comes with unique challenges, but it comes with unique opportunities. We have learned a lot of lessons, but here are a summary of some which might help others who are thinking of building such an infrastructure for their own domain, or managers like me who want to enable different kind of research within their department. That first and the most important lesson I learned was that collaboration is the key. We worked very closely with our team, our colleagues at FASRC, NERC, HUIT, to enable to optimize our computing resources. We work closely with researchers across the university to understand their need, to understand what product would better serve the larger community, and how we can make a customized solution into a generalized solution which can be used by many people. Then scalability is very important. To design a solution that is scalable both up and down, vertically and horizontally, is very important when we think about an infrastructure like that. And embracing automation, a lot of our projects where we automated them, we moved a lot of our work which was done manually was automated and moved to cloud. And choosing the right tool again could save you a lot of hassle going forward. And no one solution for all, but choosing the best tool for the job was what we used here. And I would say it was not a one shot that we got the solution which I presented. It was an iterative development process for many of the solutions like climate raster information which we presented. We had a version 1, then we iterated it to develop a version 2 that was more efficient. So what you are saying is version 2, and probably next year we might have a version 3 which is even more optimized. So it's not a final solution, it is an iterative development process that we are using to refine our solutions. And many processes were moved from commercial clouds to our own in-house cloud and cluster computing resources, which saved in thousands of dollars of cost. And in academia, I think that is very important cost saving, because that could be put to other uses if you save that hardware and that infrastructure cost. So that is something we focused on a lot. And we monitor our performance continuously on FSRC and NERC, and there are inbuilt tools which help you to monitor the GPU memory to see how well your code is optimized, which helped us a lot in kind of what is the next iteration and where do we want to go from where we presently are. So these are some of the lessons. These are more general. They don't apply only to spatial data, but I think it applies to any this big undertaking of building an infrastructure for a domain. And I know I have passed on a lot of information. It's a lot of diverse information that I have conveyed in this, which is so to get everything in one place so that our users know where to go and where to find these resources if they are looking for a particular thing. We have built a project website. So I will like to walk you through quickly to the project website. So when you go to our project website, on the left you will see all the resources which I just described in my presentation. So if you are looking for data sets, spatial integrated data sets, social media data sets, you click on data sets developed. Here you will see the list of data sets which are available. And when you go on any data set, click on any data set, you will see how description of the data set, how the data set was developed. Then you will see the publications, the use cases, how other people are using this data set, and also information on how you can access the data set. So we provide link to the website or the Harvard Dataverse page where the data set is available for you to use. Then similarly, all the GI the spatial solutions, the customized solutions which we have developed, whether it's for raster data processing, whether it's for calculating k nearest neighbor, you can click on that and you can read about what the solution is, what software it uses. Most importantly, you can see how other people are using, what are the use cases and publications. Some papers are published. You can go and read into the full manuscript to learn more. So all this information is already on our project website. Then we have deployed systems on FastRC and NERC, and we provide information about all these systems. So on FastRC, these are the geospatial systems which you could use. And when you click on any system, you can go and see, and we have our video self-led tutorial which will tell you how to use PostGIS on FastRC and what are the use cases and how other people have used it. Similarly, on NERC, you can go and see if you want to launch ArcGIS Enterprise on NERC. How do you do that? Where do you get the machine image to do it? Every information is there for you to read into, and also the corresponding publications and work in progress. As I said, we have acquired licenses. We have acquired licenses of data and software like StreetMap Premium. If you want to use StreetMap Premium, the information is all here. How you can use this global StreetMap Premium for your data sets and how you can acquire the license from us. We also have the software licenses. These are the different geospatial software licenses that are available and the information on how you can use that. Uh, Learning resources, a lot of learning resources. This part of work is still in progress. So you have the self-less tutorials, which are short videos on getting you started on using these tools. And you also have the full day workshops recorded where you can look into specific topics, whether you want to use Python, you want to use ArcGIS, you want to use NIME or other data set, or you want to use PostGIS. Then you have full day workshops with hand-on training and these recorded video, which are open access for anyone to use. As I said, there's a lot of result that has been produced by the work. We have our publications all documented here for anybody who wants to read into the actual manuscripts and read into the use cases. Our publication are all listed here. You can go and see. And this is again the publication not only from CGA but our colleagues across the university who are using these solutions. Uh, and this is our link to our GitHub repository where you can go and grab the open source code for the software and you can edit it to your own use case. So these are the key parts of the website. Again, the testimonials on our colleagues, which describe on how and what tool they have used and how it has helped them for their research. Lastly, I would like to just thank a lot of people because, as I said, it's a result of collaboration. Thanks to our Office of Vice Provost of Research for funding this effort, and my colleagues at Harvard CGA team who have put in years of hard work to get this completed. And my special thanks to our colleague at FES-RC, NERC, and HUIT for providing all the computing and technical support they have done us for this projects, and our collaborators, our industry collaborators who have provided the software and data licenses for their projects. Thank you very much, everyone, for listening, and I'm open for questions now.
We did have a that is so cool in the chat, as in addition to a question. So do you have publications talking to what work you had to do to glue various pieces together, showing where you built custom code and what it was built in?
That's a great question. That's a to-do on my list to get this publication out because it's a different kind of publication. It's not a one research case, but we talk more about the infrastructure. And there are two parts to this question. One is the publication that is on to-do. As I said, we are working on this draft. The other part is gluing the different solutions. I don't necessarily think that we need to glue them. Some parts need to be glued together, but some parts can work independently. Like the raster information system has nothing to do with the shortest travel time or something. Some of these solutions are independent and they have independent publications because they have independent use cases. But the infrastructure in whole needs to be glued together for it to work. As I said, that the data needs to reside next to the process, because otherwise, if that gluing is not there, that doesn't work. And the different tools you need to understand, have a good understanding of the different tools to choose the best solution for depending on the use case. So I am not sure what type of gluing is mentioned in the question,
The
but
infrastructure gluing is what I was
yeah,
mostly asking for because folks are looking for things like, okay, you've got an API, you've got an AI engine, or you have an API, or you have some infrastructure over here. What did you have to do to stitch those together so that they can then repeat the kind of process?
exactly. Mhm.
Yeah, so like where you are using like heavy AI to do SQL generation, you also have to have a front end for chat. And in the back end, there's certain data it's going against that you need to have tools to scale and not scale down. And so the question is really sort of like, where is that a service? Like, you know, FASRC, you're just using their services and what the name of that service is, versus where you had to do things like custom Python coding to hook things together. It'd just be helpful to know where, because it helps people know not only the components, but like what their own development group might have to have in terms of skills.
That's a great question, and I completely agree to that infrastructure gluing part. Now I understand that the question clearly. So yes, a lot of gluing needs to be done in terms of skill. For example, many things work well in Python, but sometimes you need a database at the end, right? Especially for big data. If you have Python and Post just talking together, that makes it more optimized. And I was saying the optimization was something we kept in mind a lot. So that kind of skill gluing and software to software gluing, or and also commercial versus open source was another thing we had in mind, right? Sometimes we have a solution from a licensed product, and when people leave Harvard, they don't have that license anymore. So how can we make it a combination of commercial plus where we need commercial, but where we can use open source so that people can continue using. So that kind of gluing between our solutions between open source and was also one thing which we worked on a lot on how to optimize that work. And the most difficult gluing I think was between gluing between FastRC and NERC, right? There's a infrastructure to infrastructure gluing also, because see, if I have my GeoTweet data, it's residing on FASRC. It's a 10 billion tweet data set, 5 terabyte. You cannot, even to transfer, you will take weeks. But now your solution is on NERC, right? Your software is on NERC. You are running on JS Enterprise. Now you want to handle geo tweets. So that gluing is the most difficult part. And we have been thinking of how we make that easy, that your spatial data is somewhere you don't have to actually move the data. Literally without 10 terabytes of raster moving is not easy. That took us more time than actually running the process, because you move 10 terabytes from local to New England Research Cloud. That itself, that doing was the most tricky part, I would say here.
Yeah, but hopefully that's 1 or 2 times amount of work as opposed to things which are also consistently, constantly running, like say when you're running a service for National Geographic.
Exactly. Yep.
And we have a few more questions in the chat. Heavy AI provides a number of tools. Did you only use Heavy IQ, or did you also employ some of their other offerings like Heavy DB, Heavy Connect, Heavy Render, etc.?
That's
I'll
a great.
start with that one. It's a three-part question, but we'll give you a part at a time.
Okay. Yeah, so we used HeavyDB a lot because that's the spatial database. And also one reason of using HeavyDB is the open source part of Heavy, right? The other are licensed part. When you get into rendering, it gets into licensing and all. But HeavyDB is open source, community available. So where visualization is not needed, in cases where you don't need visualization, you can use HeavyDB just to do your analysis on GPUs. So that's where we use HeavyDB a lot. Then when it comes to rendering, we use Heavy Immerse, their front end, to do that. Again, Heavy IQ is something we recently started working from them on the Gen AI part, but all their other offerings have been used in parts and parcels in different projects. So we have a lot of experience in using different parts of Heavy.
And then does CGA make Heavy AI licensing entitlements available to the Harvard community?
It's available to the Harvard community to use, and you can reach out to us to get the latest license.
And then for your GeoTweet and TGSI work, does the project see an emerging need to expand to other platforms like Blue Sky or Threads?
That's a great question, and again, something which we are working on, because unfortunately, we have been harvesting tweets since 2010, but in 2023 that was stopped because of Twitter policy change, and we can no longer harvest data anymore real time. So our archive ends at July 2023. So it's no longer real time data, right? We are in 2025 almost. So it's 2 years back data. So since then we have been exploring other social media channels which we can use to harvest, and Blue Sky is on our radar. So we are constantly like thinking about what we can do to get. But again, Twitter is a unique animal in itself because of the short text size, right? It's easier to analyze, and the geo tweets are very unique to what other platforms are offering. So that's where we are weighing the pros and cons of getting into, and how much cost it would be to get other data sets, because you can collect 10 terabytes of data. That is not difficult, we can harvest it, but how do we use it, how do we process it, how do we make it useful for people? That's the question. Otherwise we are just storing 10 terabytes. And with GeoTweets, over the years, we have learned how to make this data set very useful to the community and how to process this large amount. So that's where we are currently weighing our other option in terms of Blue Sky and other data sets. But this is exactly the kind of feedback I was looking from today's call, that where do we go from here? What does the community need? Is there a need for Blue Sky? So one feedback which I would like from everybody on the call is, what next? What would you like to see in terms of spatial processes being brought on cloud and cluster? Have we missed any software which can be included? Is there a use case you have which was not covered in the presentation or can be covered? Or if there are particular people who come to us and say, hey, we need Blue Sky, then that is definitely something we will consider to see how we can fasten that effort on getting other social media data set. So keep these feedbacks coming.
Yeah, and then there was also a question, were the various front-end UI components developed in-house, or did they come bundled with different platforms being utilized?
Yes, so it was a mix. For some things which came bundled with some of the software we utilize, but like for example, Postgres, it does not have a visualization front end. It's a database, it's a spatial database. You can use it for analysis, but you have to use a third-party connection to visualize either QGIS or other things. So when we are using this solution, then using Postgres, then we looked into how can we build using React and other things, how can we build the platform. But some software tools like Heavy, they come with the analysis, they come with the backend, and they come with a front end. In that case, you don't need to do that. And also, I think it depends a lot on the use case, how complex your visualization is. Right, I can say I will build a React application for a very complex use case, but that might take me long time and cost to do it, rather than just building it out of some solutions like IGS Enterprise, or which already has a visualization front end. So again, it's not one solution, but it was a case by case basis where we decided whether we need to build that in-house or we have an out of box solution which can support that visualization.
And what thoughts does the group have as far as, other things they'd like to see, or any feedback from what you heard today?
I mean, not to be selfish, but with Harvard's needs as a university for analysis, which may have involved spatial things, have you turned yourselves to any sort of Harvard administrative uses? So like helping people with class paths and class spacing choices, and dealing with the fact that, we have remote workers who have spread all over the place. Have anybody in the administration talked to you about how could we use some of these tools to optimize for Harvard efficiency?
That's a great topic, and unfortunately not the one that we have touched in this project, because we focused on research use cases. So at CGA, we focus on what questions, what research needs are coming to us for spatial. People come to us with questions. These are not our questions. People said we want climate data. Our colleagues, our researchers, they come up with a use case and say, hey, I have this spatial problem, help me solve it. Right, so that kind of question did not come to us, or that was not, but that is something definitely, if it could help, if any of this work could help, we would like to expand it to other
It's just
areas.
interesting because you're using Harvard licenses that are available, not just to Harvard researchers, but, to all of Harvard. And in that case, it may be interesting to the administrators who are, searching for solutions.
Exactly. So if somebody is looking into using this, we would be happy to discuss, because we would like to understand more the needs. Particularly, I don't understand the administrative need as well. So we need, as I said, it's collaboration. Somebody needs to explain us the requirement, and then we come up with the solution. We work to implement the solution. But if it could be used in other places apart from research, I think that would be the best use of all the work that has been put in. The more widely it can be used, the better.
And a couple thoughts did come into chat, as far as promoting Heavy AI as an available tool resource, cookbooks and docs on when to use HeavyDB versus PostGIS, and perhaps some assets available via WMS.
So it's a first one is a question, like promoting heavy DB as an, is it a question or
These
a?
are thoughts, so I think this is like suggestions or feedback for your group.
Oh, I see. Yeah, that's good. So yeah, Heavy AI, we have been trying to tell people it's been with us. Heavy has been working with us for many years now, and we have been trying to tell people that it is available, and still the work is in progress. But in terms of when to use heavy DB and Postgres, is again, it's not a straightforward answer, but just if I had to say in one line, as I also described in my presentation, Postgres is open source. It is a CPU oriented spatial database. So if you don't have GPU needs, there is no need to go into a GPU database, because GPU itself are very expensive, whether you run heavy or you run any other tool. When you go to GPUs, we are talking about a much increased cost compared to a CPU only solution. So we have to very carefully weigh the project and see, is there a real need of a GPU database here? We just don't want to use GPU because it's cool and it will give us cool visualization, but what the use case is. So again, if you are not wanting to use, many people prefer not to use licensed software. They look into open source software which they can use later, even once they graduate from Harvard, so that the solution is not locked to a license from. So they are these are very few points which can on a broad level be considered between heavy and Postgres. And Postgres again has, it's a very old spatial database. It has a lot of very complex spatial analysis can be done in Postgres. A lot of spatial function has been inbuilt, and they are a lot is getting into heavy too, but Postgres has a lot of spatial functionality already enabled. But again, when it comes to GPU, when it comes to high scale visualization, then we need a GPU database. That's where heavy takes over. But again, there are a lot of technicalities which go at the back end, not of knowledge of both the software. This is a broad level, which I would say that it depends on your use case and how much you want to invest in your project. And is that investment really what is needed to spend on those GPUs? That's when we bring heavy into picture. And what was the last question? Some assist.
It was a suggestion, I think perhaps some assets available via WMS.
Yeah, we have a lot of WMS resources from our word map, which was not which has been earlier built. I will share the link on this chat. Harvard word map, which is now part of S3. So if you look into this, you will get this project. You will get a lot of information about the WMS that have resources or layers or datas which are available.
Well, I know we're a couple minutes past time, but thank you so much, Tavika, for sharing and answering questions. It was lovely to have you. And we will be sharing out the recording and the materials, so stay tuned for that. But thank you, everyone, for your participation today.
Thank you so much for the opportunity and everyone for tuning in. And feel free to reach out to me on my email if there are any follow-up questions. Okay, bye everyone. Have a good day.